Hello there and welcome to Pandas Challenge Day 6. My name is Valentine and I'll be your instructor. In this challenge, we are going to be going through a set of concepts in relation to the Pandas library that will allow us to be able to perform data manipulation, data cleaning, as well as data analysis using the Pandas library. So let's get started. The first thing that you need to do is to click on the link in the description in the description section. It should take you to this page, and then you can click on the sample practice resource, which should take you to this particular page. And we can now use this particular notebook to get to go through the challenges in relation to Pandas. So pause the video and do that. Just go to that link. Once you get there, you can click on File, then go to Save a Copy in Drive to save a copy of this notebook so that you can be able to make save any changes that you make in your Google Drive. Right, so once you have done that, I'm going to just open mine in playground mode. You don't have to do this because I don't want to make any changes. And I'll also use a practice notebook. I won't use the sample notebook. The sample notebook has just a few challenges. With the practice, you have lots of challenges. So let me even just zoom in a bit. Right, so once you have gotten to have saved a copy, you need to click on Connect to connect the notebook to Google servers, and then we can get started. So we'll start off with the prerequisite section. So we need to import the Pandas library. Let's run this code cell. Once we do that, the next concept, which is the first concept that we're going to be learning is how to display the last 5 records from a data frame or within a data frame. In order to just get an idea of the last few rows of our data, they might be helpful to just ensure that we are able to understand the last entries in the data set that we have. So we load our data set using the pandas read CSV function, store it in the df variable, then we term it as a data frame. And then we apply the tail function to the pandas data frame. Here we're specifying that we want 5, but essentially you don't need to you don't need to specify that you want 5 because by default the tail function gives you the last 5 records, but you can specify how many records you want inside the parentheses, maybe 6, 10, but the number has to be less than the number of records in the data frame. So if I run this, I should be able to get the last 5 records within this data frame. As you can see here, we have the last 5 records within this data set. Right, pause the video and then work on the challenge. The next concept that we are going to be going through is sorting by multiple columns. So assuming that we have this data set that we have loaded, and we would want to sort the values by department. So you might have multiple, we have multiple departments. We would want to first of all sort in ascending order the department column. So you sort the records in based on department, and then sort again using salary. So once we've sorted in department, we would sort using the salary column. So you will find that for the columns that we have, for the data that we have, if we have the same department, let's say IT, our salary records will be sorted in terms of in descending order. So you'll have the bigger values coming first, then the lower values coming last. So yeah, so that's what we do here. We sort, we apply the sort values function to the data frame that we have here, and we specify that we want to sort by. Then we specify a list as a value for by parameter. So we specify the first column we want to sort by, and then the second one, and then we add. Also, we then use an ascending parameter, and we use we set its value to be a list with true or false values, which correspond to the columns that we have here. So for this particular true that we specify here, we're just saying we want to sort department in ascending order, and salary, because it's false, in descending order. And yeah, we display the sorted data set. So if you look closely, you'll see that we have our sorted data frame we've sorted it in, well, the department's actually one. We could have sorted it differently. But when you look at salary, you'll see, let's say for IT, we have 97, 97, 96, etc. All right, so moving on, pause the video and then work on the challenge. We can also perform data type conversion using asType function in Pandas. So if we load this data set and preview it, so this is the data set that we are going to be working on this particular challenge. We can display the data types using the dtypes property. So we run this, and we can see here we have the employee ID has int 64 data type, first name, last name, up until location, up until here has the object data type in Python that we would consider that is textual text values. So salary on the other side, salary over here would be you can see here we have integer, but normally that would have float, and joining date, its object, normally it would have date time. But our focus for now, it's just to convert, say, salary from integer to float. So we would use the asType function. Then we specify the type of data type we want to apply to this column, df salary. And yeah, we make changes. We replace now the original df column with now the new column that has the new data type, and then we print out the new data types. So if you run this, you should be able to see that salary has initially it had int 64, here it has float 64. Pause the video and then work on the challenge. We can also identify duplicates based on specific columns. So sometimes we can decide to, assuming we load this data set, we might have duplicates, but how we define the duplicates would be that duplicates would be records that have specific columns being the same. So if we have maybe, yes, we can define duplicate as a record that has that looks similar to another record because of the fact that it has similar values. But we can decide to define duplicates as just records that have, you know, maybe 2 columns or 3 columns similar to other columns, other records within a data set. So for example, to be able to, we can decide that if employee ID for 2 records or 3 are the same, in the same case with the email, it means that we have a duplicate. So we could have these different values, but if we have this as this email value being the same, and as maybe another record with another email, and the employee ID and the employee IDs are the same, then we can define that. And we can also decide to just define one as shown, so we can remove what you have here. But essentially what we do, we specify the column names, the column, the data frame that we want to work with, square brackets, then we say the column, the data frame, we apply to the data frame the duplicated function. Then inside it, we specify the subset parameter and give it a list of column names. And we say that we want to keep, sometimes you might want to specify how you'd want to, let me even just show the documentation for that if you scroll. So you might want to keep certain records. So if we specify, say, keep to false, it means that all the duplicates would be marked. But if we say that we want only to keep maybe the first, let's say, duplicate, if we specify keep is equals to first instead of false, we would essentially keep the first duplicate or the last duplicate. So, and then we display the duplicates. Let's say, for example, in our case here, these are the duplicates. So here we are essentially getting all the duplicates. But if I change this to first, I will only get the first 109 and 1033. If I do last, I'll get now the other last records. So yeah, it's actually I'm just checking again the documentation. Last okay, let me just go to false. False. Actually, yeah, so technically you would get the last. I think the last does not really display clearly here, but when we specify last, we would get this record and this record. I think if maybe a different column was different, we would have been able to see that in place. But essentially, that is how we're able to identify duplicates based on specific columns. Yeah, so, and to drop them here, we identified them. Here, we just decided to drop them using the drop duplicates function. So we applied it to the data frame, and we specified the subset, the value of the subset parameter. We chose to keep the first record, and then we applied the changes to the original column. And yeah, here we just confirm whether we have the duplicates, which we shouldn't have any records. Pause the video and then work on the challenge. We can, in certain cases where we have missing values in a data set, we can decide to replace the missing values or the NaN values that we get in our data frame using mode. So that's the most frequently occurring value within our column. In many cases where we have non-numerical data or textual data, that can be a good strategy. So let's run this and we'll be able to see that this is the data set that we're going to work with. We can just check for missing values. So you can see salary has missing values. To get the mode of a column, we would specify the column, then apply the mode function and specify 0 to get the output. Because when you run this, when you apply the mode function to any column, you would get a tuple as a result. So if, say for example, if I copied this and let me create a new code cell and I run this, I should be able to get, not even a tuple, sorry, I would get this output that you see here, but I can decide to select actually mode is actually the first value that you see here. That's the mode for what we have. So just to get that value, 77,000, I can specify the square brackets in the position of the value. That's what I will be getting. And I specify that as the mode value. And then I use the fill NA function on the salary column or the column that I want to apply imputation, specifying the mode value and setting that I want to make the changes in the original data frame using this parameter in place and setting it to true. Then I check for missing values. All right, pause the video and then work on the challenge. So in the past, we've gotten to learn how to filter for data using Boolean indexing. So in many cases where we want to perform Boolean indexing, I'm using not equal to. So sometimes you might want to select Boolean index. In many cases, we usually select Boolean indexing maybe where job title is software engineer. We usually use a double equal sign. So this would be a double equal sign. Let's say if we wanted to select records using Boolean indexing, where the salary column that we have here is equals to 80,000, this is how we would approach it. But with Boolean indexing, we can say not equal to. So we want to get the other records, we would put an exclamation mark equal to. And yeah, we would filter our data frame. So we apply the condition. We define the condition as shown. And we display the final data frame, which will contain records that do not have salary equal to 80,000. Pause the video and then work on the challenge. We can also filter dates greater than a specific value. So initially, when we are working with some data that has dates, so in our case, we might have order date. In order to check for maybe get records with less than date, let's say less than would be ones that's happened before a specific date. then if it's greater than, it would be greater than. So in our case, you're doing greater than. So if we wanted to get maybe sales records, or the records that we have here that are greater than order date, so then what you can do is first of all convert the order date column to date to have a date time format. This is what we are doing here. Then once we have done that, the next thing that we need to do is perform now our filtering, which we can just simply use the Boolean indexing approach, where we specify the column, and then we specify the date that we want, and that will essentially give us the records that we want, so greater than the date. But it's important, first of all, you convert the column that you're working with to have a date time format. All right, pause the video and then work on the challenge. In some cases, we might want to maybe rank data based on a single column. So there's sorting that we did, but if we wanted to assign maybe some relative position of each data point within that data set, so, let's say if we wanted to load this data set, we'll load this data set. So assuming that we have total price here, but we wanted to rank or to give a number to each and every record, so that we know that which one has the highest price, the first one, second one, or third one, etc. Then we can use the ranking approach. So we apply the rank function to the data frame column that we want, that's total price, and then we specify the method that we want to use when ranking, which is max. So if I am to just even check the documentation for that, by ranking specifying method to max, we would be intending to have or to rank the group of records that have the same values. So if we have any ties within our ranking, maybe there are 5 records which have the same total price, then we would have the records with the highest rank coming first. It's like, how should I put it? I'm just trying to look at a good explanation. So what essentially happens is that, so let me just explain when it comes to max. So when we set the method to max when it comes to ranking, so assuming that we have one record which has the highest figure, it could be 1,000, and you have 3 or 4, just 3 records which are tied for to the second position. So if the first record has 1,000, then the second position has 3 ties. Then by setting to max, essentially what would happen is that those records would be given 4 as the rank value. So instead of giving them 2, we would give them 4, because we specify that the method would be max. If we wanted to have, if assuming that we had, let's say, 1 record that was the first one, then we had 2 records that were tied for second place, and we set the method to average, then the rank for those 2 values, they would be 2.5, 2.5, to be the average of the positions of the positions that they would end up undertaking. So that is what would happen. When it comes to minimum would be if we have 3 records tying for second place, then they would all be given the value 2. So maybe, I hope that makes sense. So for this case, instead of assigning a rank value that is the position, so let's say for 3 records are tied for second place, instead of giving them the rank 2, we would give them rank 4, because there are 3 records, but they'll be given the rank 4. So you can play around with ranking, because ranking has different approaches to it. Yeah, so that's all about ranking. So pause. Let's assign this. Let's run this. Then you can be able to see what's happening here. we have created a new rank column from total price and displayed the data set. These are the columns that we want to display for now. Yeah, so yeah, pause the video and then work on the challenge, and then we can continue. So with Pandas, we can also create some basic plots using the plot function. Yeah, so that's what we're going to learn. We're going to learn how to create a bar chart, and then in the next section, we'll learn to create a scatter plot. So let's load this data set. Before creating a visualization, we need to ensure that the data that we want for the creation of a bar chart or whatever visualization is in the right format. So we need to have some sort of summary table for a bar chart. That way we have, now in our case here, we have category, then we have electronics, office supplies. So here we have count of values for the electronics, for the category column. So in the category column, for the electronics value appears 25 times, office supplies appears 20 times. So this gives us some distribution of this variable. And then we can create the plot, that's a bar plot, by applying the function to the data frame, to the variable that we have here. This is not a data frame, by the way. And we specify the kind parameter value as bar. We want to create a bar chart, so we specify the value of kind to be bar. Here we're just setting the color of our bars within our bar chart. We're setting also the figure size. So 10 dimensions across, that's on the x-axis, and 6 on the y-axis. You can modify these values to suit whatever that you want. And we also give our title, a bar chart, the title that you see here. And we finish by adding a semicolon. So running that should give us our bar chart, and you can play around, let's say, with the figure size for that. But normally with visualizing data, we don't use Pandas as much as we would other libraries which are focused on data visualization, such as Matplotlib. All right, pause the video and then work on the challenge. Lastly, we can also create not only a bar chart, but a scatter plot. So if I load this data set, I should be able to see the data that I want to work with. And a scatter plot allows us, it's a type of visualization that allows us to determine the correlation between two variables. And to specify a scatter plot, we just specify kind, so to be scatter. So here we had specified earlier onwards kind, the value of kind to be bar. Here we're just specifying it to be scatter. Then on the x-axis of our scatter plot, we want total sales. On the y-axis, we want quantity. They need to be two numerical or continuous variables. Then we specify the title and the x label then the x-axis title as well, our label. And yeah, and we run that, and we should be able to see our visualization, this is our scatter plot. The points are not, they do not move from the bottom left to the bottom right, or from the top left to the bottom right. So it essentially means there's a weak relationship between the two variables. That's sales, total sales, and quantity. Means that as total sales increase, it does not mean the value of quantity increases, or as quantity increases does not mean that the values of total sales increases. All right, pause the video and then work on the challenge. So I hope you were able to go through the challenges and were able to practice more. We'll continue reintroducing some of these concepts as we continue. The idea again is to extensively practice working with the Pandas library, and by the end of it all, you should be a pro, a professional, or you should be an expert in just working with Pandas for either that data manipulation, cleaning, exploration, or data analysis. If you loved this video and you'd want to see us continue posting more of such videos when it comes to practice work, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future challenges, be sure to subscribe. All the best in your learning journey.